All right, we're on the air. Class is being quiet. Paige has requested number, Paige is here, yeah. A square with a perimeter of 84 times the square root of 2. So Paige is talking about a square. Paige, are you ready with your calculator?
Yeah.
If the perimeter is 84 times the square root of 2, I'm thinking maybe you could help us out and just divide that by 4.
That equals 29.7.
Wouldn't that be how big the square is on each side then? You divided it by what?
4.
All right, so you did 84 times square root of 2 and you divided it by 4. So, Paige, if you want the area of the square, by the way, this is number 7. I think, Paige, you could just take 29.7 times 29.7.
I got 882.
Correct answer, 882 inches squared. Well, I want to focus.
Okay.
Ha-ha! Autofocus is now working. Next request for Becca.
Number 14.
Becca is apparently interested in learning. Paige is talking. Okay, going on. 14 you said, Becca?
Yes.
Becca, looks like we have a circle circumscribing a triangle. And we've got a 1.5 from the center to the corner of the triangle. Stupid thing won't focus. So Paige, Becca, we have to figure out some angles here. First of all, we're going to have to do circle minus triangle. Because the circle part is shaded and the triangle part is white. So that's going to be pi r squared minus, and then we're going to use the new formula, 1/2 PA. And to help us figure out our P and our A, we're going to make a little triangle with one angle at the center, and an apothem would go like that. Becca, right here is the center, and you see this angle where I am putting a dot? You should be able to figure out what that is, because this triangle would have another one just like that here, and another one here, another one here, another one here, another. So 360 divided by how many of those to get all the way around?
Well, it's 360 divided by 3 and then divided by 2, right?
Yeah, so what are you thinking for that angle then?
It's 60.
So that's a 60-degree angle. So if I just, because my camera's not focusing nice here, I'm just going to do a blow up bigger here. I'm going to put that 1.5 there, that 60 that you said right there, and ooh, that's pretty. All right. Do you remember how to get from hypotenuse down to short leg? She's got a card on that.
So what are we saying?
For the record, Paige and Hayden are still talking
I'm talking about math.
about math.
What am I finding?
You have the long side of a 30, 60, 90, and you would like to get down to the short leg.
Would that be divided by 2?
Nice, that'll be .75, did that in my head. Then how do you get from that short leg to the long leg?
Multiply it by the square root of 3.
Can you do that quickly? You have the equipment for that? .75 times the square root of 3?
I'm getting 12.99.
No way, not no 12. .75 times the square root of 3.
Oh, 0.75, sorry. 1.29.
1.29er. All right. Now we're going to fill in our formula that we talked about. Pi. Radius, I think you can see the radius of the circle is 1.5. That's squared minus 1/2. Becca, we need the perimeter of the triangle. And to help you, remember you found this little piece right here to be 1.29. That should help you. From there to there is 1.29. What's the perimeter of that whole triangle?
7.74.
Did you go times 6?
I took 1.29 times 2 and then times 3.
Times 2 and then times 3?
Yeah.
It's faster to go to times 6, you know. What did you get?
I got 7.74.
Nice. And then the apothem, wouldn't that be this little piece? Which is really the one that you said was .75. What kind of calculator are you running there, Becca Hofer?
This one.
Oh, she's running that one. It's a TI. It looks like it's capable of taking parentheses.
It is.
So you could conceivably punch this all in at once. Tanner's scared, but you dare.
I'm scared too.
You too? All right, try it once. I'd put a parentheses around this half also, or a .5, whichever you want. And we'll check what the answer book is thinking for number 14. See how close she comes to 4.1.
Let's try this again.
It should be 4.1. Try it at home on your calculator.
Mr. Gore,
Yeah,
so
4.1.
when we found the small triangle, the hypotenuse or whatever it was, or not the hypotenuse, but that was 1.29. Wouldn't we have to double that because that small was an appium, so we only found half of the side of the triangle?
This 1.5 right here is the hypotenuse of a little triangle right here. And the 1.29 would be half of one side. So that's why she took it
When you found the 7.74, was that?
6 of those. Does that make sense to you?
So you took 1.29 times 6?
Yes. It's like one of them there, one of them there, 2 more there, and 2 more here.
Oh, that makes sense.
Seeing that, kind of?
Yeah.
So, and this isn't a perfect sketch, but you should be able to see that there's 6 of those triangles would make the whole thing, too. So that triangle right there happens 6 times in the white triangle in the middle.
I get that.
All right, good question then. Lindsay, Lindsay's putting us on to number 10 now. Ooh. It's just a regular triangle. Remember, on a regular triangle, all the sides are the same and all the angles. And they said the side length is 15.5. Now, we've actually done this problem before, did it another way, where we figured out the height. But we're going to use it with the new Apothem technology. We're going to say that this area has to be 1/2 perimeter times apothem. Well, the perimeter, that's just going to be 15.5 times 3, isn't it? 46.5? Correct me if I'm wrong. But the apothem is going to take a little work. The apothem would go from the center straight to a side, straight to the middle of a side. So we're going to make a little triangle between a side and a point there. Now, this is much like the one we just did. Since these are 60s, that makes this split 60 a 30 there. So we've got a 30, 60, 90 there. And we learned before that if you know one side of a 30, 60, 90, you can get them all. Which side of this 30, 60, 90 do we know? Lindsay.
What we did is we made a right triangle with like half of it.
Yep.
So it was like there's a difference, like the line was from the top to the bottom. Can you not do it that way? There was still a 60.
All right, so you're saying you did it the old way, and yeah, that's perfectly fine.
But we still found like the half pound, but it didn't come out right. We got 150.
Well, I guess what I'm saying is that if you put this here, these should be the same. And this is your apothem right here then. So this should be half of 15 and a half, so that'd be 7.75, I think. So, Lindsay, I think the way to get the apothem is to do a 7.75 divided by the square root of 3. That'll give you that little piece there. Can somebody give me that figure? 4 point what? So I think if you calculate this up, right down here, you should get the area of this triangle. Book says 104.0. That's what it would round to. And I agree, there's another way to do it, which is not any harder. If you just go like this, and you have your 15.5 down here, you can just go like so, and that makes a 30, 60, 90 right there. So we can figure out the height and go 7.75 there. This height would be 7.75 times the square root of 3. And you can just use the old 1/2 base times height formula that we learned long ago. What is that height? 13-ish? 13.4? That is just as easy or easier, so.
With half of 13.4, we thought that that was the half. So is that not right?
Oh, I see what you're saying.
So we got 6.7.
Someone has thought that maybe if they find this, they, this all the way up, that this would be half of this. Actually, it's a third. It's kind of surprising, but this center spot on a triangle is always 1/3 of the way to the wall and 2/3 of the way to the corner. So, good guess, but wrong guess. Another request? Becca. 9, regular hexagon. I probably won't fully do this one because it's all 30, 60, 90s again. This time the apothem is 24. It's number 9. The apothem is 24. We'll make another triangle with a corner and the apothem both in it. Again, we start by trying to figure out what is that angle right there. How many of those angles fit all the way around? Well, it's half of one of the 6 sides, so I think you should do 6 twice, 12, 360 by 12. You should get 30 degrees for that angle, Becca, right there. And once you know this is 24, and it's a 30, 60, 90, then this is 24 divided by the square root of 3.
Wait, so the top angle is 30, not the bottom? Like where it meets the corner?
Right, because can you see that? I'll do it in red to not confuse. This red triangle, this red angle is 1/6 of 360. There's 6 of those. That opening would open to each of the 6 sides, and that angle there then would be 60, and we've got half of it. So then you have a little 30, 60, 90, and if the long leg is 24, the short leg is 24 divided by the square root of 3. And so now you have your 2 figures that you need, because you're going to do a 1/2 PA. The A was given as 24. And the number that you put right here for the P, you should be able to see that it's 24 divided by the square root of 3, 12 times. All right, now you should grab your paper. Yeah.
Why is it divided by the square root of 3?
Well, this is the long leg, and on your little card it should say to get from short leg to long leg, you go times the square root of 3. So if you already got the long leg, and you want to go down to the short leg, you would divide by the square root of 3.
Oh.
And you were good at that once, at one time. All right, now I'm going to do number, we're going to start going on in this time. I'm going to do number, maybe 15, which you haven't done yet, but it's part of what you have to do next. So grab your papers. Try to keep up. Number 15 is a triangle with a circle inside. And we know the radius of the circle to be 3.6. I am going to ask Hayden, are you looking at the shading there in your book, son? What are you thinking of for an overall plan on this number 15? Notice the triangle part is shaded, but the circle part is not. Okay, usually what you want to do is shaded minus the white.
Okay.
So that'd be triangle minus circle. Do you know the formula for either the triangle or the circle? Formulas we use for those? Nice, nice. He's got the second part of there. Pi r squared. Paige, I'm giving you choice for this triangle. We've got two ways to do it now. We can do a 1/2 PA or we can do 1/2 BH. She can't decide. Why did I ask?
No, I can decide.
Yeah.
You mean 1/2 PA? All right. We're going 1/2 PA. Nice. It's the thing we need the most practice in, so I feel it was a wise choice. Paige, I'm going to make a triangle from the center, and I have to have one line to the apothem, which I think looks like it's there already. And then I want one to the corner, so it looks like that's the one I have to draw yet this time. And maybe I'll pick on Megan. Megan, usually it begins by trying to figure out what the angle at center is. So I'm looking at this angle right here. First of all, Megan, that angle right there, how many of those do you feel there are going all the way around? She's right, 6. And that has to add up to 360, so what degrees is that then? Yes, ma'am, 60 degrees. So that's a 60-degree angle right there. And since that one's a 90, that means this one has to be a 30 over here, and we have our wonderful 30, 60, 90 technology going again. Now I'm going over to Jacob. We've got the apothem, Jake. We're going to be needing that over there. We've got the radius. That'll go right there. But we're going to need a perimeter, which I think means we're going to have to find this side. Can you tell me how to get from that side to this side? Remember, this is the 60 and this is the 30.
Take it times square root of 3.
Yes. Opposite the 30 would be the short leg. So he's getting from short leg to long leg. So this is going to be 3.6 times the square root of 3. Who's dying out there? Who's that? Oh, that's too bad.
You've got bronchitis.
Chad, how many of those 3.6 times the square root of 3's, which I think is this piece, how many of those do I need for a perimeter?
6.
I'm just putting it all in here like this. Some calculators can do that well, they all can do it actually. Whoa. I'm going to pause while the entire audience tries to put that in their calculator.
Whoa.
Yep. I think most of your calculators will handle it. I really do. There are people out there that are not doing it. I don't know if they're lazy or don't know how to run a calculator. I can't believe it.
You said at the beginning we could take half pH minus pi r squared. Could you take 3.6 times 3 for the height? So it would be half.
Ooh, that's good thinking.
Would that work as well?
That is good thinking. That is a nice little shortcut. Only works on triangles, though. You can't do it on all your polygons. All right, the audience is getting noisy, so we're just going to keep going here. If you did this correctly, you should get a number that, when rounded to the nearest tenths, would be 26.6. Next, I'm going to do number, see, I did 17 yesterday. I think I'll leave 16 for someone else. Let's maybe try
16?
20.
Okay.
20 has a circle. In the circle looks to be a equilateral triangle. And in the triangle is another circle. Mama.
Yeah. You didn't make that clear. I should have circle and a triangle.
I would like to ask Tanner. Oh, Tanner's busy with something. I'll ask Matt Johnson. He's always with me on this. Matt, looking at the shading of this number 20, do you have any suggestions for an overall plan?
Would it be the area of the big circle
Big circle?
minus the area of the triangle
Big circle minus triangle
plus the area of the small circle?
plus the little circle. Sounds good. So I'm just going to sketch that plan as a reminder here. Big circle minus triangle plus little circle. Because that little circle is shaded and therefore added in. So I'm going to do pi big R squared minus, I'm going to do a 1/2 BA Matt Johnson method, I think. BH, I meant. My audience has a sick mind. All right. The only figure we know on this whole thing is 8 to the corner. I'm now going to make a little triangle right here
Why is it a capital?
to keep my big radius and small radius apart. So I think I already know big radius is 8. Now I'm going to go to Matt Johnson, who is a equilateral triangle specialist. He totally understands the fact that the center of an equilateral triangle is 1/3 of the way to the wall, 2/3 of the way from the points. Now, Matt Johnson, if this is an 8 right here, you're telling me you know right off what that is.
4.
4, how'd you do that, son?
Because if the whole thing is 3 times the apophthegm, then half the 8 would be 4.
Yeah. So if this is 2 parts and this is 1 part, the parts must be 4 and that missing part must be a 4.
I'm confused. Why is it?
So Matt, if I'm doing 1/2 base times height here, you're saying the base, do we know that? Or do we have to do a little work yet? How much is this part right here, Matt?
That should be the 4 times square root of 3.
That boy is good. Paige and Hayden are talking about math again,
Now we are,
and they're giggling.
because we understood.
Alright. So Matt Johnson is saying that the base of this triangle is probably 8 times the square root of 3. And Matt Johnson is saying that the height of this triangle, which would be all the way from here to there, what are you saying, Matt?
It's gonna be 12.
It's 12. He totally sees the 2-to-1 ratio there. He understands that this would fit right there, so all the way across one of these is 12. Kid's a natural. He's after my job. Let's see. He has to have 2 more years of high school, 4 years of college. I don't know if I can wait. Yeah, I can probably wait. What's the radius of the little circle, Matt?
4.
All right, punch it up, kids. Unless you're a slacker, you want to just sit there and talk about math.
We are.
Yep, I got people not even trying. Shoot, I don't even know if all my kids have calculators. So depressing. Think they could at least just fake it. Make me feel good. If you are a calculator entering specialist, by now you should have gotten 168.2. And I believe that's where we're going to end our request time.